These are the most important diagrams every business analyst must know. The business process diagram, the system diagram, the entity relationship diagram or class diagram, and the state diagram. For each of those 4 diagrams, I will explain what it concretely is, how it does look like, and why you need to know this diagram. Let's start with the first one, the system diagram. A system diagram in the end is a diagram to show how a system is structured in an architectural and structural way. With a system diagram, you can directly see how systems are interconnected with each other. To give an example, you could imagine a user interface. A user is using an interface. After clicking a certain button, there is a back end, a middle layer, which in the end is doing an API call to a database. And based on this request, the database is giving back a response, and the user is seeing the response of the database. And this behavior here can be modeled in a system diagram. A system diagram could look something like this. Here you can see 2 systems, System A and System B. System A contains of application 1 and 2, and System B contains of application 3 and 4. As you can see, application 1 and 2 both can access each other, and application 2 has access to the database. And you can see System B has access to application 2. That's a traditional system diagram. You can see which application or which system is interconnected with each other. For example, if there's a change in the database, you know that application 2 is directly affected and application 1 and System B is indirectly affected because these components are only directly connected to application 2. So whenever the database changes, you also know that probably in application 2 something has to be changed as well. And that's the power of the system diagram. Then jumping to the state diagram. Let me explain this one with an example. Let's imagine you have a data object, a bank account. And whenever a bank account gets created, so you're onboarding a client, a bank account has a status or a state active. And of course there are other states a bank account can be in. For example, you can close the bank account, then you have a closed state, or you can deactivate the bank account, then you are inactive. But of course you can activate the account again and you're back to active. But also you can close the bank account in the inactive state. And here you can see which states can a data object, in this example a bank account, be in. This diagram helps the developers to really understand how you can traverse from status A to status B and which combinations are not possible. For example, you can go back from a closed state to an active state. And this diagram says so much more than 1,000 words. Just imagine plain text to explain the states. This diagram does it a lot better. The next diagram I want to show you is the entity relationship model, or also the class diagram in UML. But in this video, I will just focus on the entity relationship model. The entity relationship model, or ERM, is there to show you how entities, or let's say data objects, are connected to each other and what their relationship is. Let's again have an example. We have accounts, bank accounts, and we have parties, so clients of the bank. And a party can have multiple accounts, and an account can be owned by multiple parties. So you can have joint accounts, right? And this relationship between these entities is an N to M relationship, so multi to multi. There are other relationships too, but this one is the most complex form. An account could be defined by the account ID, a status, and a currency, and the party could be defined by a party ID, the name of the party, and date of birth, let's say. Each of these entities can also be represented as a table in the database. For example, here you can see the table for accounts and the table for parties. For example, account 0 is active and the currency is dollars. Party 0 is James and was born on the 1st of January 1990. Now this end-to-end relationship means there is also a relationship between account and parties. And here you can see in the yellow table the relationship. For example, account 0 is owned by party 0 and also account 1 is owned by party 0. So this party has multiple accounts. But also you can see that account 1 is not only owned by party 0 but also by party 1. So account 1 is a split or a joint account for multiple parties. And this is how you can really see this end-to-end relationship between these objects. So it's a bit more complex than having an easy one-to-one relationship. The entity relationship model is really good for showing the developers how data objects are connected with each other. Just imagine to explain the developers in a requirement in plain text how these accounts and parties are connected, that you can have multiple on each side. This diagram tells it so much more easy and specific and efficient. Now lastly, probably the most important diagram is the business process diagram. The business process diagram is a well-defined diagram with a start and an end and has a timely perspective. So from left to right, we are traversing through time. That's the difference of all the other diagrams before. This one is dynamic, not static. For example, in this process, you can see on the left-hand side, when it starts, a loan request was received. So let's say you are working in a bank and your application is registering that a new loan was requested. The first activity here is to check the credit score of the client. Let's say a credit score is a number which can be positive or negative. Here we check in the process, is the credit score of the client positive? If so, we accept the loan request and the flow ends in this path. But if the credit score is not positive, we reject the loan and that's it. Imagine again explaining this requirement to a developer in plain text. This diagram is doing it so much more efficiently and accurate. Here you can really see what is determining the decision, right? The credit score. So it's really easy to see what the decision is like. A diagram or a picture says always more than 1,000 words.